So a definite integral is the way of expressing the signed area under the curve of a function. So if I have a function, I'm just going to draw any function. I'll say this is a function of x, and I'm going to pick a couple of points on this function. I'm going to put a point here and a point here. And I'm going to call this A and B. So let's say I wanted to find the area under the curve of this function from A to B. So in other words, we're talking about this area that I'm shading in purple. Well, the way we write that is the integral, let me just do it down here, the integral from A to B of the function of x, and then with respect to x, so we write a little dx there. I'm going to pull up a little reference guide for integrals, so you may want to take a screenshot of this or whatever so you know what it means. So we have our integral sign right here. Then we have lower limit of integration, so that's where we start taking the area. And we have upper limit of integration, that's where we finish. We have the function that we are trying to find the area of. It's right here. And then we have the differential to clarify what variable we are using. Now, in case any of this seems a bit confusing, I'm going to do a few problems relating to definite integrals. So for our first problem here, we have here a graph of a function, f of x, and we're asked to find the integral from 0. Let me just mark this on the graph here. So here's 0 to 5 of this function. So let me just put an altitude right here so it's clear where we're finishing. And then I'm going to go ahead and shade in the area in purple. That way, perhaps I'll shade this part in purple and this part in red. So we're looking for the integral from 0 to 5. Now if I have the integral from 0 to 3, and if I add it with the integral from 3 to 5, it makes sense that that would give me the total integral from 0 to 5. So I can write this as the integral from 0 to 3 of f of x dx plus the integral from 3 to 5 of f of x dx. And I can calculate each one of these areas using geometry. So I'll start with the purple one, integral from 0 to 3 of f of x dx. Well, I have a right triangle here. Notice that this has side length of, side length of 3. This is also side length of 3. So we know that the area of a right triangle is 1/2 the base, which is 3, times the height, which is also 3. 1/2 times 3 times 3 is going to give us 9/2. So that's the first part of the answer. The integral from 0 to 3 of f of x dx is 9/2. Then we have to do the second part, integral from 3 to 5 of f of x dx. That's what I've shaded in red. Now we have a semicircle here. This blue arc is a semicircle. And it has radius 3. So if I had the whole circle here, it has radius 3. And I know the area of a circle is pi times the radius 3 squared, which is, in this case, it has radius 2. We're going from 3 to 5 here. This has radius of 2. So this will not be a 9, but this will be 2 squared is 4 times pi. Now to find the area that I've shaded in red here, well, that's a quarter of the whole circle, so I have to divide this by 4. And of course, the 4's cancel out, and we're just left with pi. So coming back over here, the integral from 3 to 5 of f of x dx is pi. And then all I have to do is add these together. And this is a total integral from 0 to 5 of f of x dx. We'll do a couple more problems. So for this one, we're given a function but not a graph. So we're going to have to draw the graph of this one. So here's my coordinate plane. function is the absolute value of x and then minus 1. Now, if it were just the absolute value of x, it would look something like this. But it's minus 1, so it's shifted down by 1 unit. So I'll draw it like that. Hopefully it's somewhat to scale. And we're looking for the integral from negative 2, which is going to be around here somewhere. If I can put that point on the axis, to 1, which is where they intersect over there. And because this is the absolute value of x minus 1, this point down here will, of course, be at y equals negative 1. And then this is 1, and this is negative 2. And let me draw this in. So the area that we're looking for is going from negative 2 to 1. So I'm going to shade. Now, notice that some of this is below the x-axis. So that tells us that it's going to be negative area under here. So I'm going to do this in 2 parts again, the way I did with the last one. I'm going to start by writing this as, by the way, this point right here is at negative 1, where it intersects the x-axis there. So the first part is integral from negative 2 to negative 1 of this function, absolute value of x minus 1 dx. And then we add this with the red part, which is the integral from negative 1 to 1 of absolute value of x minus 1 dx. And again, we can find each of these areas using geometry. So for the purple area, we have right triangle. This length here is 1. This length here is also 1. So we have the area of the purple triangle is 1/2 the base, which is 1, times the height, which is also 1. And this is just equal to 1/2. So for the integral from negative 1 to 2 of the absolute value of x minus 1 dx, this is equal to 1/2. And because we're above the x-axis, that is a positive area. And for the red, well, this length right here, we're going from negative 1 to 1. So this length is 2. Let me use a better red. It almost looks like purple. This is length 2, and then my height right here, I'm going to put this in green so we can see it. This is my height. This is 1. So the area of the red part is, it's not red. Is 1/2 the base times the height, which I'll keep in green so we are sure. And if you work this out, 1/2 times 2 is 1, times 1 is still 1. But because we are below the x-axis, it's going to be a negative area. So my integral from this right here, my integral from negative 1 to 1 of absolute value of x minus 1 dx is going to be a negative 1. So my final answer is going to be 1/2 plus negative 1, which is just negative 1/2. All right, I'll do one more problem. All right, once again, we don't have a graph, so we're going to have to draw one. This function might scare you a bit, but hopefully you'll recognize it as the equation for a semicircle with radius 3. So here's my semicircle. Let me see if I can draw it a little bit better. So it has radius 3, so that means that this point right here is going to be negative 3, and that's going to be 3. So let me just label those. This is negative 3. This is 3. And of course this right here, put a point there, is 0. And we're interested in the integral from 0 to 3 of this function dx. Now, just like we did in the first problem, I'm going to go ahead and draw the whole circle in. So I'm going to finish off this semicircle, make it a whole circle. And so the area of the whole circle is pi times the radius squared, and this has a radius of 3. And this is just 9 pi. And to get the area of the purple part, well, that's a quarter of the whole circle. So I have to divide this by 4. And that gives us our final answer here, is 9 pi over 4.